Good morning, people. We're going to talk today about periodic table calculations. We're going to take what we have already learned about the structure of an atom, about the protons, the neutrons, and the electrons, and we are going to apply it to the periodic table. And we're going to use the periodic table to calculate the numbers of each of those subatomic particles in each kind of atom that is on the periodic table. Once you know these rules, they'll apply to all of them. So let's start with a typical entry for a carbon atom. A carbon atom is always going to have the number 6 at the top. That's because 6 is carbon's atomic number. The atomic number determines the identity of the element. That is super, super important. And it's the number of protons. Those positively charged particles. So every carbon atom out there has 6 protons. Now, most atoms are neutral. That means that the number of protons, which are positive, equals their number of electrons, which are negative. When you add the two together, you get 0, which is a neutral atom. So that means that the atomic number not only tells me the number of protons, but it also tells me the number of electrons. The number of electrons doesn't determine the identity of an atom because that number can change. But protons never ever change. Remember that. The next thing you're going to see is the element symbol. Don't worry about memorizing these because truthfully you're going to use them so much and look at the periodic table so much that you're going to get familiar with these and you're going to have a lot of them memorized. The last thing you're always going to see on a periodic table entry for any atom, for any element, is this number we call the atomic mass. It's always a decimal, and it's always bigger than the atomic number. And it is a weighted average. Average means it's calculated, okay? And what they have done is they've taken the mass of all the carbon atoms out there, applied some fancy math to it, and this is the number that we get. Now we know we can't have 0.01 of an atom, okay? Now remember, the only two subatomic particles that contribute to the mass of an atom are the protons and the neutrons. The electrons are that funny word, negligible. Their mass is so small it doesn't really count. So when we talk about mass, we're only talking about protons and the neutrons. So we round this number to the nearest whole number. In this case, 12.0 rounds to 12. And we call that our mass number. And it is the number of protons plus neutrons of the atom. Okay? This means that most carbon atoms out there have a mass of 12. And so to calculate the number of neutrons, you need a man. Take your mass number, subtract your atomic number, which is your A, to give you your number of neutrons. Man. So in this case, we're going to have a mass number of 12 minus atomic number of 6 to get our number of neutrons, which in this case also happens to be 6. That won't always be the case, but sometimes it works out that way. So let's do a practice problem. This is fluorine. Fluorine is atomic number 9 on the periodic table, so it's just a couple of spots over from carbon. Atomic number 9 means that this is the number of protons and also the number of electrons. So what we need now to calculate is neutrons. So the way we're going to do that is we're going to take the atomic mass. 18.99 rounds to 19. So I'm going to take this mass number of 19, which remember is protons plus neutrons. I'm going to subtract my number of protons. Okay? That leaves me neutrons. 19 minus 9 is 10. Fluorine, the most typical atom of fluorine, has 10 neutrons. That's all there is to it. We're going to do some more practice in class, and we'll see you then.